In 2025, the world woke up to a new reality: storms, fires, floods, and quakes arriving with shocking frequency. Across continents, headlines repeat the same words: unprecedented, record-breaking, catastrophic. Tonight we ask the urgent question: why is the planet reacting so violently? And what message is it sending to humanity? Warm oceans have transformed into enormous energy reservoirs. Super typhoons now draw power from higher sea temperatures and sustain winds far longer than before. Storms that once weakened quickly now strengthen as they cross ocean basins, carrying destructive force straight into coastal cities and changing how we must prepare for every hurricane season. Floodwaters rise faster than rescue teams can respond, turning neighborhoods into islands within hours. Urban drainage systems, designed decades ago, are overwhelmed by extraordinary downpours. Entire communities find themselves cut off, roofs becoming lifelines.
Hey, over here.
These are not isolated incidents. They are repeating patterns linked to a changing atmosphere holding more moisture. Across continents, forests ignite under conditions of long-lasting drought and relentless heat. Fire behavior has shifted: fast, unpredictable crown fires that jump roads and rivers. The scale is different. Entire mountain ranges burning, forcing mass evacuations, destroying habitats, and sending plumes of smoke that circle the globe and affect air quality thousands of miles away. Scientists watching global data are sounding alarms. Small average increases in temperature ripple through ecosystems and weather patterns. Feedback loops accelerate warming and destabilize local climates. This isn't speculation. Models and observations together show that the more we heat the planet, the more likely extreme weather becomes, and the faster change accelerates. Historic temperature maps show a clear trend: blue zones shrinking, red zones expanding. Heat anomalies concentrate in regions previously considered temperate, pushing ecosystems beyond their tolerance. The result is unpredictable rainfall, extended heat waves, and unusual storm tracks. These shifts ripple across agriculture, infrastructure, and human health in ways we are only beginning to measure. Deforestation accelerates climate impacts by releasing stored carbon and removing nature's own cooling system. Machines raise forests, soils dry, and local rainfall patterns shift. Areas once resilient now face cascading effects: lost biodiversity, weaker water retention, and higher flood risk. The loss of forests is not just local damage, it reshapes global climate dynamics. Ice that formed over millennia is now breaking apart in dramatic collapse events. Glaciers calve into the sea, ice shelves fracture, and polar habitats shrink. For wildlife dependent on stable ice, survival becomes a struggle. For coastal communities, melting poles mean long-term sea level rise and increased vulnerability to storm surge during extreme events. Disasters are rarely isolated. One event triggers another. Loss of vegetation leads to soil erosion, which increases landslide risk after storms. Droughts prime landscapes for megafires, and fires then create runoff that causes sudden floods. These domino effects amplify damage and complicate recovery, turning single events into complex humanitarian crises. In places like Southern California, fires have reached scales that outpace historical records. Entire hillsides are consumed. Communities are forced into rapid evacuation while first responders battle impossible fronts. The cost in property, air quality, and human stress is immense, highlighting how climate-driven extremes now define local disaster profiles. Heatwaves in Europe are becoming a new normal, driving daytime temperatures to dangerous peaks and stressing power grids, hospitals, and supply chains. Vulnerable populations, the elderly, outdoor workers, children, face acute risk. Infrastructure designed for milder climates fails under prolonged heat, revealing how adaptation must be immediate and systemic. Monsoon and seasonal rain patterns are shifting, producing record rainfall where it was once moderate. Rivers overtop, levees breach, whole districts are submerged.
Just hold on
Rescue
tight.
efforts face toxic waters, damaged roads, and lost communications. These floods expose gaps in preparedness and the need for resilient urban planning that anticipates a different hydrological future. Seismic events continue to remind us of Earth's dynamic crust, but when human systems are weakened by climate impacts, earthquakes produce multiplied suffering. Damaged infrastructure, stressed emergency services, and compromised supply lines intensify the aftermath. Preparedness must therefore consider compound risks, not single hazards in isolation. Tornadoes and severe convective storms are appearing in unexpected regions and with greater intensity. Supercell storms produce larger hail, faster winds, and longer paths. Communities with limited tornado history now confront a hazard for which they are unprepared. This expansion of risk areas challenges assumptions about where extreme weather can occur. Drought transforms once productive landscapes into cracked plains. Wells run dry, crops fail, and livestock suffer. Water scarcity becomes both an environmental and social crisis, forcing migration and heightening conflict over dwindling resources. In a hotter world, seasonal rains are unreliable, and traditional water management systems break down. Satellites paint a stark picture of human influence, glowing hotspots of emissions, dark smoke plumes, and land use change visible from orbit. The scale of our footprint is undeniable. These data help scientists link emissions patterns with local warming and extreme event frequency, making the connection between human activity and planetary response clearer than ever. The oceans bear multiple wounds: warming, acidification, and plastic pollution. Marine ecosystems degrade, fisheries decline, and coastal communities lose livelihoods. Floating debris also interacts with storms and currents, spreading ecological damage. Addressing climate and pollution together is essential to keep oceans resilient and maintain the services they provide humanity. Air pollution overlays the climate crisis, worsening public health and compounding heat stress. Cities shrouded in smog see higher hospital admissions during heat waves and wildfire seasons. Pollutants interact with atmospheric processes, sometimes altering local cloud formation and precipitation, another reminder that environmental problems are interconnected.
The data
Global
is
leaders
unequivocal.
and scientists
We have reached the
assembled to
tipping point.
confront this
Indeed.
reality.
Failure to address
Emergency
these challenges will have
code red
catastrophic
warnings
consequences.
and urgent policy talks. But summits alone are not enough. Coordinated global action must translate into measurable emissions cuts, finance for vulnerable regions, and fast deployment of adaptation measures to protect lives and economies. There is reason for hope. Renewable energy deployment is accelerating. Wind farms and solar arrays expand across landscapes, offering scalable alternatives to fossil fuels. Technology and investment can reduce emissions quickly if policies, supply chains, and social acceptance align. Transitioning energy systems remains a cornerstone of reducing future climate extremes. Public pressure is growing. Youth movements, community organizers, and local leaders demand action. Grassroots energy creates political momentum and holds institutions accountable. Collective voices push for faster policy change, stronger regulations, and investments that protect communities, especially those on the front lines of climate impacts. Restoration projects show that recovery is possible. Planting trees, restoring wetlands, and regenerating soils rebuild natural defenses against floods and heat. These nature-based solutions sequester carbon while increasing resilience. Small acts, when scaled, directly contribute to reducing future risks and improving local livelihoods. Cleanup efforts in oceans and rivers illustrate how civic action can reduce one form of environmental harm even as we address larger climate challenges.
We are now
Removing
deploying the
debris
collection
protects
system.
marine life, improves water quality, and restores ecosystem function. Local actions compound into global benefits when coordinated and sustained over time. Successful rescues and rehabilitation of wildlife demonstrate humanity's capacity to repair some damage. Returning animals to safer habitats and rehabilitating ecosystems sends a signal. Recovery is feasible with commitment, science-based planning, and long-term stewardship that values biodiversity as essential to planetary health. Children and future generations are the most affected by today's choices. Their eyes reflect hope and vulnerability. Protecting their future requires education, equitable policies, and investments that reduce emissions while building resilient communities. The moral dimension of climate action is urgent. It is about justice for those yet to come. From space, the planet can appear fragile yet resilient. Oceans, forests, and clouds shaping a living system. Recovery is possible, but it depends on our collective choices. Science gives us the roadmap, emissions targets, adaptation strategies, and clear evidence of what works. What remains is the will to act decisively and at scale. At sunrise, a single silhouette stands and watches the earth below. This image is a call to action. The future is literally in our hands. The choices we make now about energy, land, and community will determine whether the next decades bring catastrophe or renewal. Act now, for tomorrow depends on today.